Alright, we're starting 15.2 day 1, which is rational exponents in radical notation. So I'll explain what all of this means and then I'll tell you how I remember it and we'll just go through examples. So when we are looking at rational exponents in words, a rational exponent is a number raised to the power of m over n. And that is equal to the nth root of the number raised to the mth power. So notice that mth power is on the top, the nth root is on the bottom. And again, I'll show you a way to remember that. So with numbers, if we have 8 to the 8 to the 2/3, 8 to the 2 over 3. 2 is going to be our power because that's in the m place on the top. And 3 is going to be our root, because that's in the n's place, which is on the bottom. So what's on the top is always the power, the bottom is always the root. So then this turns into a cube root. This 3 goes on to the root. That 3 tells us it's a cube root of 8 squared, because that 2, that power, goes here. Now, one thing about the power is that the power can actually go on the outside with parentheses, or we see we have 8 to the 2/3 again. 2 is still the power, and we actually put it on the inside this time with the 8. So that power can go on the outside or on the inside. Depending on where we put it, that makes the steps look different, and sometimes one way will be better than the other, and we'll keep talking about that. So if we put the 2 on the outside on this one, the cube root of 8 is 2, so that's where this 2 came from. This 2 is our power, that's squared, just hopped over here, and 2 squared is 4. But if we put the power on the inside, this time we're looking at the cube root of 8 squared. Well, 8 squared is 64, and the cube root of that is 4. So again, we'll do more examples slower than that in a second. So algebraically, what this means is that if b is greater than 1 and m and n are integers, where m is greater than or equal to 1 and n is greater than or equal to 2, because we have to have at least a square root, then this is true. b to the m over n equals the nth root of b to the m, remember the root and the power on the outside, or the root with the power on the inside. And here's one way I remember it. So I drew a tiny picture here of a tree and the sun. So we have two words we're looking at, power over root, because the power is the number on top, the root is on the bottom. Well, how do we remember that? If I look at this picture, the sun is at the top of the picture, and the power comes from the sun. You know, the power of the earth really comes from the sun. If we didn't have the sun, then we could not exist. So that's where the power comes from. It's the sun. And then the roots of the tree go down into the ground. They are on the bottom. So that's how I remember. The power of the sun is on the top. The roots of the tree are on the bottom. So it's the power over the root. So let's write in radical notation. If we have 2 to the 1/4 power. Well, on the first few, I want us to label. The 1 on the top is the power, and the 4 on the bottom is the root. Power over root. So there are two ways that we can write this. We can write it with the power outside or the power inside. So first, with the power outside, this tells us we're going to have the 4th root of 2 to the 1st power, because that is the root. So the 2 goes inside. That 4 is our root, a 4th root, and that power can go either on the outside or the power can go on the inside. So this is the 4th root of 2 to the 1st power, 4th root of 2 to the 1st power. Those are both our answers, but really when we have a 1st power, we don't have to write that. So these really just equal the 4th root of 2. Let's look at another one. X to the 3/2. Well, the power is on the top because of the power of the sun. Roots are on the bottom, roots of a tree. So that means this x is going to go inside, and this 2 is our root. So this is actually square root of x cubed. Now, when we do a square root, do we have to write that too? No, so that equals just square root of x cubed. That's one of our answers. Or we can put the power on the inside. So this could also be the square root of x cubed. But again, I didn't need to write that 2, so that's just square root of x cubed. Those are both our answers. And you need to be familiar with both, because later on when we do problems where we have to go further than this, sometimes this will be better, sometimes this will be better. Okay, let's do 2 more. 6x to the 2/3. All right, well this one we have parentheses, and when we have multiplication on the inside with a power, we actually give that power to everything inside. But on this one, I'm going to leave the 6x together. So that 2 is our power, 3 is our root. So that means we have the cube root of 6x to a power of 2. So we have a cube root of 6x all squared. That's one of our answers. Or we can do the power on the inside. Cube root of, and this time I actually need to keep the 6x in parentheses on the inside because we are squaring this whole thing. The whole 6x has that 2/3 power. So that's going to be squared. So these are the 2 different answers. Both are correct. Sometimes one will be easier than the other. Another thing we can actually do with this problem is give that 2/3 to the 6 and do 6 to the 2/3 and x to the 2/3. And then we would go from there. We would have the cube root of 6 squared times the cube root of x squared. Or you could put those squares on the outside. But we'll see more like that later. All right, last one of these. We have 3x to the 4/5. Well, the 4 is the power, the 5 is the root, but this time be careful. That 4/5, what is it going to? Only the x, not the 3. So I'm actually going to go ahead and just write the 3, leave that alone because it does not have a fractional power. So that 3 is just a normal 3. Then we have the 5th root of x to the 4th. So we can either do that with the 4 on the outside, or we can do the 4 on the inside. Make sure that the index is very clearly attached to the root, because we don't want to get confused and think this is 35. This is 3 and the 5th root of x to the 4th. So these are the answers. All right, so when we have a problem, we actually have a couple of methods, a couple of ways that we can approach it. So if we're looking at 16 to the 3/2, I'm going to show you the 3 ways to approach it. The 3 is the power, the 2 is the root. So method 1 is when we put the power outside of the root. Power outside of the root. So this tells us we have a square root. So that's going to be square root. Remember, when it's a square root, you don't have to put an index there. The square root of 16, I'm going to put the power outside of the root. Square root of 16 cubed. Well, this one we're actually going to evaluate it. What is the square root of 16? The square root of 16 is 4. So now we have 4 cubed, and 4 cubed is 64. So 16 to the 3/2 is 64. But another method to get there is if we put the power under the root. All right, so we still have the power is 3, the root is 2, so we know we have a square root of 16, but this time we're going to put the power under the root. Well, 16 cubed, we can actually, you could just put that in your calculator and write out that big number, but I'm actually going to put them side by side by side. That makes it easier because we know the square root of 16 is 4. The square root of 16 is 4, so I'm bringing a 4 out of the root, 4 out of the root, another 4 out of the root, because I'm just taking square root, square root, square root. And 4 times 4 times 4 is 64. The third method is not one we'll do as much, but it will come in handy later, is to break up the fraction. And this requires us to remember how to use exponents. So if we have 16 to the 3 over 2, we can actually break that into 16 to the 2 over 2 times 16 to the 1/2. Because when we have the same base and we're multiplying, we add the exponents. So 2 over 2 plus 1 over 2 is 3/2. Well, 16 to the 2 over 2 is 1, so that's 16. And 16 to the 1/2, 1 is the power, 2 is the root, so that's going to be a square root of 16 to the first power, which is just 16. Well, the square root of 16 is 4, so we have 16 times 4, which is 64. So those are some different ways to approach it. So now let's actually do some problems. We have 27 to the 1/3. Well, 1's the power, 3 is the root, so that means we're going to have the cube root of 27 to the power of 1, so that's just the cube root of 27. Well, now we need to break that down. So 27 can go to 3 and 9, 9 can go to 3 and 3. And remember, when we do cube roots, we're looking for groups of 3. So I actually see 3 3's here. That means I can bring 1 3 outside of my root. If you need to, if it helps you, we could actually write this out. The cube root of, we got our prime numbers, 3, 3, 3. That is a group of 3 things, so we brought out a 3. So our answer to that one is 3. All right, let's look at -8 to the 4/3. Well, we need our power and our root. So this is going to be a cube root of -8. And we have to decide where to put the power. Generally, I start by putting the power on the outside, and I ask myself, is this a perfect cube? Can I make -8 into 3 things that multiply by itself? So -8 is actually going to be -2 times -2 times -2. Remember, when there's an odd root, we can have a negative inside. So the cube root of -8 is -2. Now we have -2. We just bring down that power. -2 to the 4th power is 16. Let's do a couple more. All right, what if we have 4 to the -3 over 2? -3 over 2. All right, well, we need to look at our power and our root. -3 is our power, 2 is our root, so this one is a square root of 4, and then again, I'm going to start with the power on the outside and see if I can make it work that way, and if not, then put it on the inside. Well, the square root of 4 we know is 2, so this actually equals 2 to the -3. What do we know about negative exponents? To make a negative exponent positive, we actually take it to the bottom of our fraction. So 2 to the -3 is equivalent to 1 over 2 cubed. Remember that? And then 2 cubed gives us 8, so it's 1 over 8. Let's try another one. We have 16x to the 4th to the 3/4. So this time we have 2 things on the inside, and what I'm going to do with this is give that 3/4 to the 16 and to the x to the 4th. We can do that because it's multiplication on the inside. So 16 to the 3/4 and x to the 4 times 3 over 4 is 4 times 3 is 12 over 4. We are doing 4 times 3 over 4. Well, 16 to the 3/4, 3 is the power, 4 is the root, so that's going to be the 4th root of 16 cubed. And then x to the 12 divided by 4 is 3. Well, the 4th root of 16, let's see if we can break that up. 16 is 4 and 4, 4 is 2 and 2, 4 is 2 and 2. So the 4th root, we look for a group of 4, so we can actually bring a 2 out of the root. I'll bring this over here. Equals 2, and then don't forget about that cubed, and we have x cubed. And then, of course, 2 cubed is 8, so 8x cubed.